Hello, how are you? Okay, right now I'm going to start a discussion for YEC practice 3 for Bison and Flex for calculator language 2. And actually the purpose of this discussion is to the end of this week, I will need you to submit the proposal for your term project. In order to provide you more information on how can you start the project, term project option 3, I would like to have one more example and actually two more example, calculator language 2 or like calculator language 3. And my purpose of giving you this is actually want you to get started for this for the YEC and Bison project for the project 3, the term project option 3. Based on the knowledge that I provided in this talk, you can actually copy all the code that I have and add whatever you own for yourself for your term project. But you have to think about what I can put into this term project more. And actually, I do encourage everybody to try this option because, in fact, this is the way that you learn more for this programming language course. Because if you learn more about how to construct a compiler, even though it's not a complete version, at least you learn a lot from the experience. And I believe this experience will be very useful not only to the compiler design, but also for any project that you have in computer science and also even for your job interview in the future as well. So first, let's look at this calculator project. In calculator 1 project, actually, we have an interpreter-based calculator, but it only accepts single-digit numbers, and also it only accepts integers and plus minus sign, and do not allow this kind of do not allow the variable, do not allow the parentheses, do not allow the multiplication. So this calculator 2 project, we add more features into it. Even though the plus and time sign still do not have the precedence, but we actually allow the parentheses to provide a precedence to make sure that you have the proper order to be evaluated for the expressions. So the depth file, part 1 is like this. This is for the YEC version, so we do not have a calculator 2.tab.h, but they do have a Bison version in my directory, so I'll show you that. And actually here is very much the same, except that right here we have a variable, and this variable is a single-digit variable. I'm sorry, single-letter variable name, and this single-letter variable name will hold a value. That value actually is the variable name minus a. So that is actually from lowercase a to z, that would be 0 to 25, and that will be corresponding to a simple table entry sim. And other than that, the integer is still the same. We convert the token string to the token value, and this token value will actually be returned to the parser. I'll show you later. And actually, operators will increase from plus minus sign with the parentheses, equal sign, and the star sign, and division sign. And that operator symbol will be returned to the parser as a operand, as an operator, sorry, as an operator, and this is and any wildcard letter other than this will be invalid. Space and tab will be ignored, and pass3 will add one YY wrap. That's the next program. For yet program, actually, as you can see right here, available is actually available is a variable, and a statement is a expression, or it will be a assignment that has a variable equals one expression, and that variable actually is $1 that actually got the value from this YY text string minus A, that would be, and YY text only allow single letter, lowercase letter. So you will get a number from 0 to 25, and that will be a array sim. That will be symbol table defined here for integer type. And then you will get a value from this expression result. That will be $3 and assigned to that symbol table. So this is the global variable or global holder symbol table for this language. And then the expression can be an integer or a variable. And the variable will directly get the value from the symbol table to the variable tokens value. Or you have the plus minus time or division or parentheses with expression that will assign different value to it. And there, at the beginning of the parser program, you declare two token type, integer and variable type. And the plus sign and minus sign, time and division, both are left associative. And you declare one symbol table. Okay, now let's look at the code example. So for the week 3, let me draw up this web page. Right here, you will have this slice. Click it, you will see the slice for this Flex and Bison tutorial project 3. And also, you have a PDF file and a Bison example for chapter 4. This will be the copy of my current CDF file. Under this Flex Bison, the CDF file, you will get this CDF division 2, C development division 2, and that will include the Bison 1, Bison 2, and Bison 3. Today, I'm going to talk about this Bison 2 and Bison 3. So Bison 2 program, we actually have one Bison file that's calculated to.y, let's open it. This is the EX or Bison file. So we declare a simple table of 26 entry, and then 2 token type, and then we have net associativity for these 4 operators. And the program is the program with a statement, and the statement can be an expression or a variable equals expression. If it is an expression, then we print out the value it has. So when we propagate up to this, we have a button-up evaluation back to this expression. This will directly print out the value for the expression. And if it is a assignment, we have the variable equals expression, and that this value for the token will be minus by, let me open it as well. Let me open the calculator to that L file. Okay, so on the left-hand side is the lex file. On the right-hand side is the EX file. So right here you got a number one. Number one is the return value from this character value minus A. That will be 0 to 35 assigned to YYL value, and YYL value is returned to here. And then get the symbol table entry. And in fact, if you have only and this will assign to the variable value, and actually the variable value is coming from the expressions value, and this variable value to the upper level become an expression. You actually will assign the symbol table value to the expression value. And other than that, you perform the calculation, plus minus time division, same as the calculus 1. And also, if you have only one number, that will return with the integer. And then, for expression with parentheses, you will just get the number. Get a number to the expression's no value. Okay. Now, let me actually close this. And right here, go to Bison 2. So right here, I have BO1 and BO2. Let's look at the BO2. BO2 is the one that process the calculator to EX file, and then we actually combine with the table. With TXT, we generate one token table definition file, .h file, and then feed that definition file to calculator.l, and then we compile for the calculator 2. So let's run it. On top of this Bison 2 directory, let's run. Shift and right mouse click. Shift and right mouse click, and then click open command line. Right here, let's run this BO2. The program has been compiled, and then you type calculator 2 and start to do A equals 3, B equals 6, C equals A plus B, D equals 3 times 5 minus 4. And then now you should actually do A plus B without assignment. I'll give you 9. And then you do C, I'll give you 9. And then you do C plus D. So apparently this one can finish the more complicated arithmetic function, and we get out from the program. Now let's look at Bison 3. Bison 3 project, we also have one Y file. And we also have one Lex file. So these two files actually including the greater equals, this kind of thing, while, if, else, and print. And I am not going to discuss the detail how this is designed, but I will show you how to run it, and then you can start by yourself. And I'll give you more tutorial next week on the calculator 3, but not right now. So to run it, again, you go to the directory for Bison 3, shift right mouse click. So Bison 3 file is open. Now I go into Bison 3. I have a program called Sample Calculator 3. I open with Notepad double plus. I open the wrong file. I should open calculator 3.y. Okay, so that's the calculator 3.y file. And I have this sample program written in the format that is supported by this language, that it allows the if, while, and greater equal, those kind of tokens. So now let's run it. Shift open. And you can compile it using BO1 or BO2. Let me use BO2. I'm sorry, BO1. This project only has BO1. After that, you run calculate 3, and then you need to redirect from sample.calc3 to direct the info file from console to a file. I'm sorry, you should run calculator 3. Hey, there are 3 versions. Okay, so actually this one start with x equals 0, and then when x less than 15, we print it out and then increase the number. So this program run properly. And hope you enjoyed it. And I just give you a show lecture, and hope you enjoyed it. And let me know if you had some problem. And these 2 files, Bison 2 and 3, are intended to help you to choose and perform on the project option 3, and you are allowed to copy my file and start from there. Okay, thank you. Bye-bye.